So hello everyone, welcome you back. Our today's topic is digital and analog input output modules of PLC. There are two types of input devices and output devices that is to be connected to the PLC. First is your input devices and second is output devices. In input devices there are the two types. First analog input devices, then digital input devices, and also in output devices like analog output devices and digital output devices. How these inputs and output devices like analog and digital is to be connected to the PLC by the using of digital and analog input output modules. So first we will see the definition of digital and analog input output modules of PLC. See here, in a PLC system, inputs and outputs module act as an interface between PLC CPU. You can see here, this is your input module and this is your output module, and this processor memory is your PLC CPU. You can see here again, there will be a input addressing. The input addressing indicates that this is your input modules or input devices. This is your input devices like push button, limit switch, etc. Whatever you want to add, you can add here like a input devices. And this output addressing indicates that this is your output devices like motor, circuit breaker, or such type of devices. And this is the interface between the input devices and output devices, your input output modules. This is your analog input module or digital input module. Then input receive signal from field devices and output send control to the output. This is your definition. Then the second, input and output arrangement are built in a fixed PLC. There are two types of PLC. First will be compact PLC and second is your modular PLC. In compact PLC, the digital and output modules or input and output modules are fixed. And in modular PLC, there are the slots like input module, output module. You can change input output modules like here, first input module, your your first input module, then second input module. There are total six input output modules. Then in next we have see one diagram like digital input module, AC digital input module. Here is a diagram. So first focus on this diagram first. This is your digital input module diagram. You can see here IN0, IN2, IN4 up to the IN15. This is your input terminals, like total 0 to 15, like total 16 input devices you can connect to this module. And is the upper side, you can see here, this is your input status indicator or input device status indicator. Then this is your one switch, this is your second switch or second and third switch, like so on. The number of inputs and input devices is to be connected. First, this is your switch off and on, this connected to the IN0 means input terminal 0. Then your selector switch like manual and auto is connected to the input number 4, and low sensor switch is connected input number 8, high sensor switch is connected input number 12. Then one of the terminal of the input device is connected to the 24-volt DC, like plus means here plus and here your minus. Like one of the terminal of the input device is connected to the plus 24-volt DC, and the second terminal of the supply is connected to the common terminal. This is your common terminal. This supply is connected to the common terminal, and the other terminal of the input devices is connected to the input module. You can see here other terminal is connected to the input module. Then inside the input module, there will be this circuitry is available. There is one circuitry. If we consider ion 0, then in that ion 0 this circuitry is available. If you consider ion 4, means input 4, then in that input 4 this circuit will be available. All the 15 input module, this type of circuitry is available. Then we discuss this block diagram, input module block diagram. So we can consider here AC input module. To move to the block diagram, first will we see there are some basic requirement to the input module. Like the basic requirement is all the switches or input devices. This your input devices or switches. All the switches or input devices to be connected to the input module. This is your input module. All the switches and input devices to be connected to the input module, the voltage is same is the basic requirement. Means which devices you will be connected to the input module, all the devices the input voltage is same. If the input voltage of one devices is 120 and the other devices that the voltage is same like 120 volt, this is your basic requirement. Then focus on your block diagram. Then here we consider like AC input module. Here we consider AC input module. So L1 and L2 are the phase and neutral. L1 is phase and L2 is your neutral terminal. We have considered here AC input module. The AC input module works at 120 volt, 230 volt AC, so on. Then L1 and L2 are the phase and neutral. Then when the push button is pressed, when this push button is pressed, the signal is passed to the input module. This is your input module. This signal is passed to the input module. Hence, but my supply is AC. But my CPU, the PLC CPU works on DC supply. Hence, we connect here a bridge rectifier. The bridge rectifier converts AC into DC. Then there will be a Zener diode level detection. Next, your Zener diode level detection. After AC is converted into DC by the using of bridge rectifier, the Zener diode allows current to pass only when the voltage is high enough. If the input voltage is low, the Zener diode does not conduct, so the PLC remains off. When the voltage reaches required level, the Zener diode conduct and turn on the opto isolator. Turn on this your opto isolator. So the PLC reads the input as on. This also helps to avoid false signal and protect the PLC from high voltage. Then after that there will be a opto isolator. This is your opto isolator circuit. Is used to separate the high voltage AC field signal from the low voltage. My internal PLC circuit, when the input signal turns on to the internal PLC circuit, like low voltage is required to the PLC. When the input signal is turned on, the LED inside the opto isolator and the light of LED activates. In that opto isolator, one is LED. When the input signal is on, then the LED is glow, and this LED activates the photosensor on the PLC side without any direct electrical connection. This protects the PLC CPU from high voltage surge noise. Then there will be a logic circuit. Circuitry as available. Then next is our logic circuit. It receives signal from optoelectrical isolation and converts into a clean and standardable digital signal that the PLC CPU can understand, and the output is clear 0 and 1. The output is clear 0 and 1. Next we will see the electrical diagram. Next we will see the electrical diagram. So this is our electrical diagram. This L1 and L2 terminal is our phase and neutral. This fuse is to be connected for the protection purpose, or MCB also we will be connected for the initial stage is protection purpose for the fuse and MCB also. Then there will be a push button. Push button is input device. One terminal is connected to the input module terminal strip. This push button, one terminal is connected to the input module and the second terminal is connected to the phase supply. You can see here, first input terminal is connected to the input terminal, push button input terminal is connected to the input module, and the other terminal is connected to the phase supply. Then when the input is pressed, signal is passed through the input module terminal strip to the R1. When this push button is pressed, the signal is passed through this input terminal strip to this R1. R1 is to step down the signal or reduce the voltage level to the required voltage level. Then there is a filter. This is your RC filter. To remove the noise or etc. from noise like vibration or other devices, to remove. Then there is a bridge rectifier. To convert AC into DC. Then converted to DC. Then by the using of bridge rectifier, the converted into DC. Then the supplies go to the opto isolator circuit. This is our opto isolator circuit. It consists of this LED and this photosensor. When the input signal available LED is glow, it will emits the light. That light fall on the phototransistor or photosensor, and the phototransistor activates the digital logic circuit or give input 5 volt DC. We have connected LED status indicator. Here is a LED status indicator is glow. It showing that the input 1 is now available. This is the circuitry and first we will see the block diagram. After that we will see the internal module circuit of the device. Thank you.